Hello. So in this final video, we're going to be going over all of the questions from the midterm review packet dealing with the final unit of the semester, which was Unit 7, dealing with stoichiometry. Okay? So this will be questions 31 through 34. Now, stoichiometry is one of the tougher units of the year because it's all math-based and it's very cumulative. It incorporates things from Unit 6 when we were dealing with the mole. It incorporates things from Unit 5 when we were balancing reactions. It includes molar mass. There's just a lot of things that go into this. So, in your notes, you will have a flowchart that might help you with these problems. Also, if you look at the reference sheet, you'll see a figure that has 4 boxes, and that's really for mass-to-mass problems, but you could use that to sort of help you along the way. So let me pull that up. Okay, so here is that section from the Unit 7 box of the review sheet. So what I wanted to point out is this particular piece for now. Okay, so again, this is really the setup for a mass-to-mass problem because you can see you're starting with mass and you're ending with mass, but you can see that it gives you some hints along the way. To get from grams to moles, you use the molar mass. To get from moles of one thing to moles of something else, you have to use the mole ratio from your balanced equation, and to get from here to here, going moles back to grams, you again would use a molar mass. Okay, a couple reminders. When you write your molar mass, you would always write it like this. 1 mole equals whatever the mass is in grams. So how you would plug that into your setup depends on your units, okay? And your mole ratio would be moles of whatever you were given, so let's just call that substance A, to moles of whatever substance B was. And in these blanks would be the coefficients from your balanced equation, okay? Now, if you have a question that's not a mass-to-mass problem, like a mole-to-mole problem, we still can use this flowchart. We just would be starting here and ending here. Or let's say you had a grams-to-moles problem. Grams to moles, you would just stop when you got here. Okay, so please remember that this is here for your reference. And we will use this as we look at question 31. Okay? Okay, so in question 31, it says, if 5.5 moles of calcium carbide, which is CaC2, reacts with an excess of water, so that's just describing the reaction, look for those question words. How many moles of acetylene, C2H2, would be produced using the equation below? Now it says it's already balanced, so we don't have to do that, but we want to make sure we know which two we're dealing with. We're concerned with the CaC2 and the C2H2, okay? So, since it's giving us moles and we're asked to find moles, that means we're starting here and ending here along our chart. So we can see it's going to be a one-step problem. We just need to show our work now. So let's start with the number given in the problem, our 5.5 moles of CaC2. And remember, make sure you write the unit and the formula. Okay. Now, since I have moles of CaC2 in the top, I need to put moles of CaC2 in the bottom. Remember, it says to use the mole ratio from our equation. So here's CaC2. There's no number in the front, which means it's a 1. So we'll write 1 mole of CaC2 in the bottom per 1 mole of C2H2, because again, it's a 1 since there was nothing in front of this in the formula. So coincidentally, moles of CaC2 will divide out, but we can see that our answer is still going to be 5.50, but that just means we will make an equal amount of C2H2 for every mole value of CaCa2 that we start with, okay? So, mole-to-mole problems are the quick ones. They're one step, and again, all we're doing is using the coefficients from our balanced equation, okay? So that's question 31. So now if we move on to question 32, let's take an assessment here. So how many grams of CH4 are needed to produce 50 grams of CHCl3 using the equation below? So again, it's already balanced, so we're dealing with this one and this one, okay? But we see now that it's grams and grams. So this is going to be a mass-to-mass problem. We'll start here and go all the way to here. So we can see it's going to be long, okay? Our known would be the number we were given, so that would be the 50 grams of CHCl3. And the unknown would then be the CH4, right? Because that's what we were asked to find, the CH4, okay? So if that helps thinking of it in terms of the actual formulas, feel free to write it like that, okay? Now, we need to start with the number printed in the problem. So the number printed in the problem start as far left as you can because we're going to have a lot of work here, will be the 50 grams of CHCl3. Now, it says that we need to use the molar mass of CHCl3. So we'll say that 1 mole of CHCl3 equals, if we calculate the molar mass for that, it'd be the mass of carbon from the periodic table, which is 12.01, plus the mass of hydrogen from the periodic table, 1.01, plus the mass of chlorine, 35.45 times 3. So if we do all of that, we'll see that our molar mass of that thing is going to be about 119 grams. So here's my conversion factor. We just need to plug it in so that the units cancel. The gram part will need to go in the bottom to cancel out with the gram part we already have in the top of that first section. So let's write that down. And our molar mass is always based on 1 mole, no matter how it's balanced in the equation. Okay, so that's going to cancel grams of CHCl3. We're at moles of CHCl3. The whole point of that is so now we can use the mole ratio from our balanced equation. Now, as we wrote here, notice that they are both balanced 1 to 1. So even though it's not going to mathematically change your answer, we do still need to include this step. So CHCl3 has to go in the bottom so that our units cancel. And then our CH4 would go in the top. Now that's going to divide out moles of CHCl3. And we have one last step. So to go from moles of CH4 to grams, once again, it says to use the molar mass. So now we'll need to calculate the molar mass of CH4. So we'll say 1 mole of CH4 equals the mass of carbon plus the mass of hydrogen times 4, which you'll see that the molar mass of that thing comes out to be 16.05 grams. We need to plug in this conversion factor so the units work. Now, the mole part has to go in the bottom so that the units cancel, and our mass will go in the top. So we'll see that's going to divide out moles of CH4. We're left with grams of CH4, which is exactly what it asked for. So when you plug this into your calculator, you'll do 50 times 1 times 1 times 16.05 and write down what you get. And then you'll do 119.37 times 1 times 1, write down what you get, divide those two numbers one final time, or else you have to be very careful with parentheses. And when you do all of that, for your final answer, you would get 6.72 grams of CH4. So that's our final answer for our mass-to-mass problems. Yes, these ones are longer, but again, remember that this is on your reference sheet as a guide if that helps you at all, okay? Just to reiterate what we did here, this whole fraction here, that was a molar mass. We're just writing it as a conversion factor. This here is your mole ratio from the balanced equation. So I'll just write from our equation. And then this last step here, again, was a molar mass. Okay, and you'll always see that for the mass-to-mass problems. They're always this length, and you always have all of those steps. Okay, so now let's move on to the next question. All right, so question 33, if we take a look at this one, it says how many grams of CO2 are produced when 100 grams of C2H5OH are completely reacted. So since we see grams and grams, we know that this is going to be a mass-to-mass problem again. So this is going to be just like 32. It is going to be a longer one. Okay, so again, if you're getting stuck, I'll pull that guide up as a helper. Okay, so we have our guide at the bottom there now. Now, notice it said it was unbalanced. So the first thing we do is we need to balance this, okay? So I have 2 carbons here. So I'll put a 2 here to fix the carbon. Then total, 5 plus 1 is 6 hydrogens. So 2 times 3 gives us 6 hydrogens over there. And if we look at our oxygen, we have 4. 2 times 2 is 4. Plus these 3 is giving us 7. So we already have this one oddball here. So the question is, if I already have that 1, I would need 6 here to get to 7. So how can we get 6 right here? 2 times 3. Okay, so there's our balancing. It would be 1, 3, 2, 3 when that's all balanced. So now to do our actual mass-to-mass problem. So again, our known would be the C2H5OH, and our unknown is going to be what we're trying to find, which would be the CO2. Okay, so if that helps, you can write these things down as reminders. Okay, so Let's see, we are dealing with this one and this one this time. Okay, so let's do our setup now. So we start with the number printed in the problem. So we'll take our 100 grams of C2H5OH. To get from here to here, it says to use the molar mass. So we need the gram part to go in the bottom. So if you calculate the molar mass for C2H5OH, you would get 46.08 grams. And in the top, we put our 1 mole of C2H5OH. That's going to divide out that. Then to get from here to here, we need our mole ratio from our balanced equation. So we see that for every 1 mole of C2H5OH, again the 1 because there's nothing there, so really it's a 1. There are 2 moles of CO2 produced, because that's what we had right here. And that divides out moles of C2H5OH. The last step to get from here to here is to use a molar mass again, but now it's the molar mass of CO2. So the mole part goes in the bottom to cancel out the units. So if you calculate the molar mass for CO2, you'll see it's about 44 grams. So that cancels out those. To do our math, again, you would do 100 times 1 times 2 times 44.01, get an answer. And then 46.08 times 1, and then you would divide those two values. Okay, so if we do all of that, you would get 191.0 grams of CO2. Okay, so again, there's our math to mass problem. Now, it doesn't phrase it this way, but this will actually help us with our next question a little bit. We could label this 191 as a theoretical yield, because a theoretical yield means no one actually did this experiment to produce that much, but that would be the amount that is possible based on the amount of C2H5OH that you started with, okay? So the theoretical yield would always be just coming from a problem, right? But question 34 will ask us to compare a theoretical yield and an actual yield. So let's move to our last question of the section. Okay, so for the last question, it says an experiment is conducted. So as soon as it starts talking about an experiment, that's your giveaway that the number it's referring to would be what we would call an actual yield. Okay, because someone actually did this experiment to get that 158 grams of lead 2 oxide. But then it says, theoretically, 170 grams of PbO should be made. So it even says the word theoretical, which is our giveaway there. But even if it hadn't said the word theoretical, we would get that because it didn't say anything about a lab to get that number. It was just sort of the maximum amount possible. When we did our questions in the unit, generally you would have calculated the 170 in part A of the problem, and then you would be given the 158 in part B of the problem. But we're just sort of giving you the theoretical in the sake just to make sure we understand the percent yield concept, okay? So, knowing the amount that was possible to make and knowing the amount that was actually made, it asks what is the percent yield. So, the last thing we have in our box from the Unit 7 section on the reference sheet is this formula. So, I put it up there at the top for your reference, okay? So, as long as we have that formula, all we have to do is plug into it. That should be the first thing you write down on the test, would be that formula. And now we'll actually plug our values in. So we'll plug our 158 in the top, divided by our 170 in the bottom, and we're multiplying by 100 to make this a percent. The grams will cancel out. So if you do 158 divided by 170 and multiplied by 100, you would get that this particular person had a 92.9% yield. So the question is that good or bad, right? Percent error, you want to be low, but percent yield, you want to be higher, because the closer your percent yield is to 100, that means you made more of what was possible, right? So if these two numbers are equal, you would have 100% yield, and that's ideal. So probably not likely, but is ideal. So the higher your percent yield, the better. The last thing it asked us to do in this question, just to finish out our packet here, it also asks you to balance the equation. We don't technically need to balance it for the problem, but just to make sure we are feeling comfortable with this. I have 1 lead on the left and 1 on the right, so we'll leave that for now. I then have 1 sulfur here and 1 sulfur here, so we'll leave that. But now we have the oxygen, which is always the tricky part. So I have 2 here, plus this one is 3 on this side. But over here I have 2. So that doesn't really help us out, right? So 2 can't go into 3. So you could look at this 2 ways. You can either try to get 6 oxygen on the left and 6 on the right, or note that this oxygen here is the one that's being difficult because it's the odd one, right? So if we put a 2 in front here to make it an even total on this side, right? Because now we would have 2 plus 2, which is 4. Now that makes it a little bit easier for us to work with. You could do it that way if you would like. Or, like I said, you could go with our other idea as well. But let's assess again now. So I have 1 lead here and 2 here, so I need a 2 in front. This now gives me 2 sulfurs there, and I have 1 here, so we need a 2 there as well. And then last but not least, notice our oxygen changed again. So we have 2 here, and 2 times 2 is 4. So grand totals, that gives us 6 on the right. So we actually end up with a 3 there. So like I said, if you had tried to get 6 initially, it would have worked out as well. So that would be our final problem of the packet. Balancing this when all said and done, it would be 2, 3, 2, 2. So again, I hope these helped. If you missed any of the earlier videos, you can go back and watch for any of the questions in this packet. Good luck on your exam.